Welcome to an exciting chapter in Python, that is object-oriented programming using Python. That should be OP. This is where your code becomes much more smarter and structured and also scalable. So first off, let's understand classes and objects. And that means that we need to understand what is a class. So a class is just like a blueprint to create objects. Now, I'd want you to think of it like a recipe. You use the same recipe to bake multiple cakes, each with the same structure, but possibly different flavors. Similarly, a class should help you with the structure and behavior of your objects. That means that we have the data or the data on one side and the behavior. So the data is what you can call also the characteristics. And then the behavior, now, obviously in Python, you can call, or in simple terms, you can say the actions, right? You have for a specific object, right? And then, now, for instance, if you look at this, now, a good example would be maybe if you have a laptop, and that will be, obviously you're coding this on laptop, and you'd have a brand, you'd have storage as your characteristics, and then yeah, you could have storage, even RAM. But now the behavior here, just think about something like that, and then you'd have something like shutdown, right? Or shut down or something. Yeah. So those are the characteristics and the behavior of, say, particular object. You can have them as a blueprint, as we mentioned earlier, in terms of when talking about a class. And that means that if you have this as a blueprint, you can create new object of a new brand, maybe say HP. That will be an object, and then it has HP. That's HP brand, and then different storage, different RAM, and then you can have different buttons starting up the laptop, and then also at the same time shut it down. So ideally, that's how it will look like, right? So whereby you have the characteristics and the behavior that you're looking at, and now these are what you turn now into attributes in programming. And then for behavior, then you can just talk about them as now the methods. Okay, awesome. So that's out of the way. At least we have kind of a picture of how this will look like in terms of when talking about, say, behavior and the specific attributes to an object. Now, let's see how to define a class. So you define a class using a class keyword, and then that will be maybe could say something like my class like so. So notice you have a camel case, something to note here, and how this out like have all those case like so. But yeah, so this good practice to have either camel case or start with an case, that is. And then you notice full column, and then now we can say maybe x goes to 5. Now here, what you're saying is x is a class variable, and it belongs to the class itself. So it's going to be shared by all objects created from this class. Now let's go ahead and create objects. So you'd have something like maybe object equals to, and then my class, right? And then so we get to initialize or call our class, and then print object dot x, right? So obviously that should help us output specific, say, value to the variable x or value to the attribute x that you implemented. So if you go ahead and run this, so there will be Python. So I'm gonna get an error. Okay, got it. Okay, so then save the file. I'm gonna save the file. Then run this again, and then yeah, we should get an output of 5. Now let's go ahead and talk about the constructor method. And that will be init. So if you talk about constructor method, then you're just talking about init method in this case. So this one gets gets created whenever you're creating a new object, right? So this will automatically help you initialize values for objects. So maybe say we have an example like class, then you have some, and then obviously in this case, then I will go ahead and say def init, and then self, and then we'd have maybe name, then age. Like so, we're gonna be able to initialize our attributes using the init. So we're gonna have like self name, so, and then have name, and then you can go ahead and have self age, then have age in our case. In terms of what we talked about on initializing values for each object, we're gonna have, maybe you could create an object here and then say something like person1, and then equals, that we have person, and then we can go ahead and maybe say John, and then have the specific value 36, and then we can go ahead and print the specific, say, attributes. Now we can easily access the specific attributes using the dot syntax, maybe say name, and then you can go ahead and have, say, print p1, then dot age. So that's how you access your specific attributes to our object. So remember, p1 is our object that we're creating, and then with that object, it has specific, say, attributes that we did talk about here, specific attributes or actions or characteristics, that is, and then methods too, which are also the actions. So we haven't created any actions yet. So we just working with attributes in our case, which are the name and then age, and then we're trying to access. So we go ahead and run this, and we should be able to access the specific attributes, right? So that's the name and the age. Now we have something new here, that is self, and self is just a reference to the current object, right? So what it does is that it helps us when initializing the particular attributes. You can access those attributes all through the class. Essentially, should be able to hold all your attributes, right? So should be able to hold the name, the age, and then be able to access it all through your class. Now let's talk about the differences between the instance variables and the class variables. So you can see the class variable is something like this, and then the instance variable is something like this. Now, something you're noting is that for the class variables, as we saw an example earlier, it gets declared inside the class, right? We're going to see that. But here, so for the most part, you're going to see like it's inside the class, but outside the method. So for case, the init here is a method, obviously. And since we have these specific variables inside the method, then that will be instance variable. Simply put, the instance variables are defined inside the init method. Now we can expand it and say, let's have a class variable. That is, we can say maybe biological species. Right? And then obviously we're going to say like human, right? And then now we can go ahead and create, say, the person one, that should be John, and then the name and age. And then we can go ahead and also create person two, that will be person, and then Gen 34, like so. Now, something that will happen is that we have this here, and then we change this to person 2, like so. Then we go ahead and run it. So you notice something, right? So it's gonna instantiate person 1 object and person 2 object, right? Like so. So obviously person 2 object has Gen and 34. And then now when you wanna access the attribute, you're gonna just have p2.name, p2.age, and then that should be able to help you access either John 36 or Gen 34. Now let's understand how the class variables will come in. So the biological species. This is shared by all instances. It's going to look something like this. So we're going to say print, and then we're going to have, say, p1 dot biological species. Like so. Now, if we change this to p2, then go ahead and run this. We're going to say like, hey, both of them are human. Right? So that's how we look at it, right? So in such an aspect, then with the class variable, you should be able to cover all, say, the objects. Yeah, all the objects with the same class variable. Now, that will be the class variable that we talked about, and the instance variable, where you can create that inside the init method. Now that we have variables in our class, let's give it some superpower. Let's give it some action. That would be the methods. So in this case, then we're going to talk about, there's also two major, that is class methods. passes the instance method. Now we're going to just copy this, just make sure we don't spoil this part. They just comment it and then kind of revamp it. So to include obviously methods. Now the most common one is the instance method, and the instance method is mostly defined using the self. So you'd have something like there, and then we could say description, right? Because this description like so, and then we're gonna have self like so, and then we can say return from the f, and then that will be self dot name to access the name attribute is, and then self dot age to access the age attribute. And so there's something you're going to notice with this. So if we go ahead and access this, so we can access this here. That will be also, we're going to be using the dot syntax in this case too. So we're going to have something like p1 dot description. Now we can, at the same time, we can have this reflected for this one for our p2, which should be 10. And then we can go ahead and run this. And then we can see like, hey, it's going to just do what we have here. That is, pick the name and then pick the age. Now, what you're noticing is that with the self, is able to allow us to access the data stored in the specific object. That is, so when you're calling our method like so, so our instance method description, we can easily access the specific variables that you have here or attributes that you have. And your guess is just as right for the instance variable, not instance, but class variable. They are accessed class-wide. So there will be something like, obviously in this case, we don't want to start with the class method decorator. Just identify that as a class. And then after having our decorator, you're gonna say define, and then species, or we can say get species. And then now we're gonna use CLS instead of self, and then we're gonna say return something like all people are, and then CLS dot biological species. So obviously this should be implemented class-wide, and obviously at the same time, if you do want to modify something, maybe have something passed here, that'll be modified class-wide. So that means that if you do want to have something shared across all objects, you're going to be using, say, the class method in this case. So if we go ahead and run this, or before that, just kind of call the class methods. So we're going to go ahead and call the class methods here. So we can say print, and then that should be p get species. So we're going to change this to p2. Then run this. Let's see what we get. So all people are human. All people are human. So awesome. Now let's go ahead and talk about inheritance. And in the context of inheritance, what happens is that a child class or a subclass can easily acquire the attributes and methods of another class, that is the super or the parent class. So in this case, this should help you easily access when you're accessing the methods and attributes of a superclass. Then I should easily help you reuse code and also extend functionality. Maybe say we have class student, and then obviously in terms of when we'd want it to inherit from the superclass, we'd have pass on, so, and then it should be able to inherit from the superclass. And now we can even go ahead and define a function. Maybe say define and then self, then we're gonna say return also f, and then say, so that will be self name of the student, and then labs playing, and then let's say maybe for a basic one we could just say love playing basketball. Now if you have that, then that means that if you go ahead and now initialize this part or instantiate the method, maybe say student method, student1 method equals to, now call the student, subclass in this case, and then we're going to provide the values. That should be the name. Maybe the name could have Maurice, and then we can say the age. Let's say maybe 20, and then now we want to print. We can easily print the name, right? So we can say maybe dot name, and then we can also say now the specific method print student one dot now play. So if we run this, we're expecting it to output that the name and what we have. It's going to say Maurice loves playing basketball. So what's the thing that you're going to notice is we call the name here attribute, and we didn't have it. We don't have it in our subclass student. But since we already have it in the superclass, yeah, we have an attribute name, then it's going to just invoke that. So obviously that means that should just work fine also for the age. So if you don't want the age to, it's going to be just the same thing. So if you run that, we're going to have age, Maurice age, the specific age. Now, what you're noticing is kind of how to do inheritance, whereby you kind of just inherit characteristics of or even methods of what we have earlier, right? Because now at the same time, you can also call the methods that we have here. So that will be the description method. We could say, okay, print student one dot description. So, and then if we run this, that means that you should be able to inherit the specific method. That is Maurice is 20 years old. Kind of the description that we had here. Awesome. Now, that means that if you have changes here, they're going to be reflected in your subclass. So, say for instance, you want to introduce something, could go ahead and introduce another method. Say, define, this should be great, and then you can say return, that should be return. And then that means that if you go ahead and call the greet method here, we're going to have hello, my name is Maurice. And that goes to show the reusability of the code when now you're talking about inheritance and kind of creating a subclass of the superclass and then being able to utilize specific methods that you'll be able to use. Now, let's talk about method overriding. We have method overriding. And in this case, when you're talking about method overriding, then it's an instance where now you'd want to provide a different implementation to a method. Say, for instance, if we'd have another, say, professional practice, just to mean what person does, have self, and then we can have something like should return, maybe something like maybe self dot name is a Python developer. Now, if we have a Python developer as a description for maybe others here. Now, if you want to now override that, since we have a student that we'll be considering too, then that will look something like define, and then we're gonna just use the same thing, professional practice, and then now we just need, we're gonna talk about super when you're accessing the specific method, but for our case, we don't really need that. We could just have it as return. And then we can say, we can just give it a different name. We can say self, we can do self dot name, and then adding return. And in this case, what should happen is that if we say something like, if we go ahead after initializing, we have them initialized here. And then if you go ahead and try to say, okay, we could have a new initialization. Maybe we could have maybe person 3, and then say that we're initializing the person as XO. And then with the person, we can have, say, another name, maybe Alice. And then we can say we have maybe 7. Then now we we can have also now the student. We can have student, maybe student 2 equals to, and then it will be student. Then we want to provide the name. Maybe we could just have Jerry here. And then we can maybe say 21, like so. And now we go ahead and say something like print. Now we'd have maybe say student, and then we'd have professional practice. Like so. So those are the methods that we're looking at. We'll have this as P3, like so. And then now we're expecting that. So for the student part or the student subclass, should obviously override what you had earlier. So Alice is a Python developer, and then Jerry is studying computer science. So that's how we look at it. Now I'm sure you can now see the customization that comes with the bit of say overriding, that is, and at the same time inheritance. Now let's move to another powerful pillar of object-oriented programming, and that is encapsulation. So with the encapsulation, the idea is you want to bundle your data or your attributes and the methods that operate on that data into a single unit, and then you're gonna also restrict its access to other objects components. They should provide some level of security and also at the same time consistency around your program. So a good example that we're gonna be using is a bank ATM. Bank ATM will be the best analogy around this, because what will happen is you can press buttons and get cash, but the complex calculations and systems are hidden from you. So that's encapsulation, whereby you interact with only the necessary parts, but the other parts are hidden from you, for either security, for mostly security. Now, the way it works, that is the encapsulation is we're going to be using access modifiers, right? And these will be mostly, we've seen how we can have something public in terms of we'll be able to access this everywhere, right? And in this aspect, with the public, we saw how we had maybe particular attribute. Say, if you have an attribute like name, that's a public, say, this public, obviously, and now or public variable. Now, if we talk about, say, that's the public part, and then obviously that means that there's also the private part. So the private, in our case, is only accessible within the class. So that means that now we're gonna see how that looks like. But for private, what you need to know is you'd only use the underscores prefix to change something to private, and we're gonna see that in our examples. So let's say maybe we have a computer that we're looking at. We have a class saying computer, and then we're gonna have define our init method in it, and then obviously we're gonna say self dot, and then now have a variable private that will be, we could say max price. Our computer is, let me say, 1200. So this will be the private variable that we'll be talking about. Now, if we have it like so, then that means that if we have the sell method self, and then we have print the selling price, and then we'll go ahead and have self dot max price, max price, like so. This should call the max price that we have. Now, we can also have now define that max price, and then we can say self and then price. So obviously for this case, we're looking at modifying our price, that is the price variable here, so that we can make some changes to the price variable. And then we can say self dot max price equals to price. So the new price that we're trying to modify to. Now, let's talk about now instantiating, right? The object, right? So for case, we're gonna have our object as maybe C for the computer, and then have computer class, right? like so. And then we're going to say c dot sell. And then now it should be able to tell us the selling price, right? If we run this, we're going to see like, hey, the selling price is 1200. And that means that it's going to output this part, right? The selling price. Something else to note is that also, if you don't want to access the max price, maybe say something like c dot max price, so, and then say like, hey, let's go ahead and print our attribute that is max price, and then run that. Computer object has no attribute max price. What do you mean? So that just tells you that you can't access that private variable as you have it. So that will mean that, for instance, that's the part of even accessing it. Now, for instance, now you'd want to update the max price, then maybe say C. Obviously, when you're calling a method, again, you're gonna just have dot syntax. So that's set price, set max price, and then try provide a new value, maybe 2000, right? And then now, after providing 2000, we can go ahead and say maybe print out the C dot cell so that you can see what the cell is now. So, because you're expecting that if you are replacing, you're calling, say that the initialized attributes that is max price, then you provide a new price that is price, and then here we kind of now update the price to 2000. It should be able to reflect all through the class the max price to be 2000. But let's see what you're getting here, given the sort of oh, okay, my bad. I guess we can see we have 2000, right? So you're able to change it, right? And yeah, so I should explain that bit again. Maybe the explanation was a bit wrong there, but what we're looking at is they're saying like if we're able to access, so for instance, for our case here, we mentioned that with the private variable, we'll be able to access it throughout the, it should be accessible through within the class. So that means that if you're setting a method inside the class, you'll be able to access that private variable. Now, the other bit that I was talking about, the difference is when you're trying to call the max price, you can't be able to call that. Or when you try to maybe say, let's have it, maybe instead of that, let's have something like C, let's call max price, and then equals to 2000. And then we can try run the cell and then see if we have that kind of change. And then you can see that for our case here, the selling price remains the same, given that you can't access, you can't directly access or change the max price variable for case. But yeah, so if you want to access it within the class, as you're able to say like so, and then easily update that. So that means that you can update by using as the class. Obviously, that should save you from direct external modification for the same direction. Now we can easily see the benefit of this. Easily help you protect from accidental changes, right? So you can do something like this, and then obviously enforces rules when updating values and helps maintain some consistency in your code. Now, let's say you really want to access those particular private variables outside the class. Then the question is, how do you do that? And that's why now we have property decorator. Now, a property decorator should help you wrap a method so you can get or set or even delete an attribute value like a variable. So, for instance, let's say, for instance, you have the max price that's at 1200, and then you have the other price that you could have before access. So that would be price. Because remember, this is also a private variable given the prefix to underscores. Now, if you look at that, then if you do want to access that, remember at the moment, if you try to maybe print something like print C dot price or underscore price. So that's how we try to access it. And then try run that. So you're gonna get something like, hey, computer has no attribute price, right? So how can we fix that? So that's where now you'd have the property decorator. So whereby now for case you can have property decorator here. So it's a property decorator, as you can see, property. So that's the property decorator, and then we can define a function or our method that is price, then say self like so, and gonna say self should help us access the price. Okay, so if it helps us access the price, then that means that if we go ahead and run this again, oh my bad, price, oh yeah, exactly, yeah, so we're getting an error. So it shouldn't be underscore anymore, because we want to access this method, right? So we're not really accessing this, but accessing the method. And then the method should call the exact price. So we're going to have price. And then now, if we run it, we're going to see that we have getting none. Let's see what the issue is. Oh, okay. We had this. Maybe this was the first error we're having. So let's see. We're having, okay, we're still having now. Oh, my bad. That will be returned. We need to return that. So let's come back here and then run that again. They're gonna get 800, right? So this should just safely help someone kind of know access a particular say attribute or variable in this case, while still maintaining the custom logic of the whole the implementation. Now, in terms of when talking about Python decorators or property decorators, this part obviously is the property decorator, and then you talk about this as the getter method, and then there also comes in the other thing that will come in will be the set method. So there will be maybe say if you have price, and then we'd have the setter method, and then we would go ahead and define price and then self. So this in this case, then that means that you can update the specific price that is using the setter method. So we're gonna say new price. So and then we can now maybe say something like if new price is maybe greater than 0 self dot underscore price, and then should be able to the new price, right? So remember earlier on we weren't able to do things like this, so whereby we can directly kind of set the new price or by accessing the attributes. But in this case, that's what you're trying to change with the property decorators, whereby you can easily get the method. So for case, you can easily we did say we can get that value, and if it was a private variable, and then we can set a different value. Just kind of update that to a different value. So let's look at how this. Now let's go ahead and see what you weren't able to do earlier on using now the property decorator, that is the setter method in this case. So we're gonna say something like, we just copy this, and then after copying this, then we can have it down here. And then now, obviously, we're looking at our price. Remember the price method, getter method that you've already initialized. So that's what you're looking at. And then you can say a different price. Maybe you could have maybe 900 here. And then if you have a different price there, we can go ahead and now say something like print, and then that will be new price like so. And then we're going to say something like C dot price, right? And then we're expecting that should be updated to 900, and that we have our property decorator in place, the getter. Now, something else to note is that even though it looks like you're directly accessing the attributes, you're calling methods internally. So for instance, for this here, price, that means that you're calling this method here, right? The price method. So with that, what this allows for is the bit of the validation, right? So before we do anything, so for instance, for case here, even before we set anything, you could just have maybe say some caveats to it. You can say like, hey, if new price is above 0, or if new price is something, then allow this. So that's now the kind of the advantage of the property decorators in this case. Now let's go ahead and define how an attribute can get deleted, and that will be just the deleter method for case. So we're going to create a deleter method. We're going to say something like, hey, we've used the price, so we're going to say something like at price dot deleter so, and then we're going to define price, and then we're going to say sub, and then end. And then that means that we'd say, maybe we could say print price so, and then we can go ahead and have el to delete, and then sub, then dot underscore price. So in this case, you should just effect that part, right? So with our deleter method, that means that you can easily just delete the attribute that we perform. So for our case, we could maybe try that. Just copy this and then have it down here. So we could just comment this and then run it so that you can see that everything is working. So new price 900. So let's say comment this, and then that we want to delete, call the object, then call the object, and then call the price. Then I'm gonna say yeah, delete that, and that should do it. So if you run this again, I'll tell you computer has no object, has no attribute, compute price. It should just give you attribute error that's already deleted, and that's how it will look like. Now that was the property decorator, and we've seen how I'll be able to have it will be able to help us access values, right? So somewhere here there is property, so it should help you easily make some changes, and obviously it should give you a clean way to control access to your class attributes using the data setter and deleter method. Now let's look into one of the flexible features of object-oriented programming, and that's polymorphism. Polymorphism means many forms. So obviously in programming, what you think about is it allows different classes to implement methods with the same name. Could be almost close to inheritance, but it's not. So by now you call the same method for different classes, that is. And we could build up on what we talked about in inheritance, right? So for instance, what we mentioned is that you can have, say, as a class student, and then you can have, say, you can call the specific attributes and methods. Now for polymorphism, that mostly works on the specific method that you're looking at. So for instance, we have the professional practice and the professional practice here. So those are the same methods for both of the classes. And now that means that this we can now take this to a polymorphism concept, whereby that means that for the same method, you can call different, say, or have different tasks, or call different things. That is. So for instance, for the same method, professional practice, then we have a Python developer here, then we have studying computer science, right? So we can say, maybe say this is a person, professional practice, then we can maybe say something else, introduce to this part, or another class, right? To just reflect this too. So let's speak this, or we could just use a different example instead of same, but at least if anything, you do understand the concept here in terms of polymorphism. Think about a bit of professional practice here, kind of a concept around polymorphism, whereby if you can call the same method and then have different, say, tasks for the different methods, or have the same different things for the same method. That's the polymorphism. So we could just introduce a simple example or a different example. Maybe say we have a class animal, and then we have, say, define, and then have sound. That's a common thing to look at. And then we could say return. So that should be animal sound. So we could say animals generic sound. So that should mean, in this case, it should be able to return animal sound. So if you maybe we introduce maybe something like animal like dog, that will be that means that it's going to be a subclass in this case. And if it's a subclass, then you can also create a method for it. Just use the method that you had earlier, that is the sound method. Then we're going to say self. Then now we're going to have this one return the dog's sound, that is woof. And then we can also have, you guessed it right, cut. And then obviously, in this case, going to have animal as the parent class, and then find sound, then now return meal for the same, right? Now, with that goes to show how say we have the sound method for all these different classes, but they be returning different sounds. And for case you can say something like animals equals to, and then you can have this in a list, dog, and then you can say cat. Obviously, remember if you're having this one, we're just initializing those so that you can call on specific methods of those. So you can say for animal in animals, that is our list, and then we can now print the animal sound so that we get different sound. Print animal sound, and then now we could go ahead and run this and then get these different sounds. My bad. I need to comment this because we're deleting the price. So let's run this again. We're gonna see oof and meow. This goes to show what we said about polymorphism, whereby means many forms. Obviously, help you implement methods with the same name but different forms, right? So for case we have method here sound, then another one here, then we have that implemented. What you notice is that polymorphism simplifies codes, right? And then at the same time, you can easily reuse, say, the method that we had earlier in the parent class, or then utilize them in our specific subclasses, and then implement a different task for the same method. And as what I mentioned earlier is like gonna be close to what we talked about here, but not really the same, right? Because there's just some subtle differences, right? So what we talked about here, right? Because in this case, obviously, you can have such an implementation, and remember, so if this in this case, what you'd be doing in this case would be the bit of the overriding, whereby should be able to help you enable different, say, behavior for different enable different behavior, if anything. So for the different behavior, we're just talking about a different action or a different this case. Now, when you talk about polymorphism, pretty close, right? So because if you have it like so, then maybe introduce another, say, also subclass, then you'd have this as a polymorphism. And so for the polymorphism, just gives different implementations for one different implementation for one interface that you have. Now, let's get to close with one of the advanced structured concepts in object-oriented programming. That would be abstract base classes in Python. You can think of it as a template for other classes to use. So it defines methods that other subclasses must implement. And then the other thing is it can't be instantiated, right? But now it should be able to act as a template for the other classes. So in such a case, then we could use this implementation here and then see how that will look like. We'd have, say, this. So the changes that we're gonna make are things like we're gonna say like, hey, this is the abstract animal, and then we're gonna just call the abstract. We're gonna import. So we have from ABC module import ABC, that is abstract class, and then the method abstract method. Like so, what will happen is that for the abstract method, we're gonna have it as a decorator, and then here we're gonna just now call the abstract ABC. That is, so you can see that we're able to create an abstract class inheriting from ABC, right? So which in this case we've used the ABC module of Python, and then now that means that if you want to also define abstract methods, we're going to be using this decorator. So we could say like, hey, for every class should be able to consider this method, right? So having abstract method, so that is the sound. So that means that we are having this as a template and then forcing this for every class to use. So we'll say pass there. That means that every class should use that specific method. Because in our case, we're going to be having our, say, subclasses here inherit from the superclass that we're considering, that is the abstract class. Then we're going to have that here like so, abstract. Now, as we mentioned again, so it's going to just it should enforce the sound method or the sound abstract method. I chose that as a template that should be considered all through the other classes, right? So for instance, if we go ahead and check that and then run this, so okay, look maybe, and then have something like that, the sound, so, and then there's some method, and then now we're gonna run that, and then we'll get sound of the dog. So at that point, now let's look at the other part whereby we talked about this being as a template. That is, so for instance, we don't have method sound, then just say pass. Then that means that if you go ahead and try initialize the dog, it's going to tell you and instantiate abstract class dog with abstract method, because that's something you haven't called just yet. And if you haven't called that, then that's you'd have such an error. I'm sure now this comes to light whereby now you understand the aspect of the abstract method forcing a developer to follow the specific contract or structure that is laid out. So easily should just help you also define a set of expected behavior. So for instance, if it's sound that you don't want to be implemented for other classes, then if you have that abstract method like so, then rest assured that you're going to have that featured for the other parts. Or if it isn't featured, then it's going to throw an error, right? As we saw. Great. At least we're able to see the work of the abstract based classes, because it's able to force subclasses to implement specific methods, and also just creates a structured design pattern, right? Because now if you don't want something implemented, then you'd have that as an abstract method like so, and then it should be featured throughout the other, say, subclasses, and then obviously easily maintainable, given that you've already had this specific design patterns or structured design patterns that people should use. Congratulations, you've just completed a powerful and in-depth journey through classes in Python, from basic structures to advanced object-oriented programming concepts. Whether you're building small projects or even architecting large applications, these tools that you've learned here will help you write reusable, scalable code. Now, let's take a moment to reflect on what we've learned. So the key takeaway is like classes and objects. Whereby we talked about classes, or a class is a blueprint of an object, right? So it should help you structure with the structure. It should help with the structure and behavior of objects, right? We talked about that bit in terms of how we look at the object also. When creating object, that means that you're instantiating a class, right? The blueprint, that is a class. And then with that, you can access specific attributes with that dot syntax for your object. Something that you don't want to forget is a bit of how our object will be. The structure, that is, you have the attributes, then you have your behaviors or methods. In such a case, then that means that you can easily access them as long as you've already instantiated your object of the class. Then now you can easily access the specific attribute or the specific methods or actions in this case. Now, we also talked about the constructor method, that is the init method. And so that here, so whereby it talk about defining init method, and then this is when it pass the specific attributes, so kind of initializing your attributes. And this ties in with the class variables and the instance variables. So whereby you talk about the init helping you create the instance of variable, and then for the class variable, that will be shared by all instances, like biological species should be able to be shared by all, say, persons here, as we saw. And then obviously the instance variable, very specific to each object. So for instance, we have John, name, and age, and then we also Dan's name and age, that is. Now, went a bit further, talked about now class methods, and this ties to an understanding of also class variables and instance variables, where we have class methods and instance methods. So if we talk about instance method, then we're talking about the specific objects. Then the class methods, obviously, we're talking about this operates on class level. So obviously, and then we did see that we're going to be using CLS, and then that means that we'd have a decorator class methods that consider this as a class methods, so whereby should be accessed by all the methods, not methods, but objects that we'll be able to create here. Now, the instance method are very specific to individual objects that we'll be creating. So the instance methods are these ones, right? That has self, right? Or the self is the one that should help us easily modify the different, say, attributes or different methods that we have in the classes that you're creating. And that's how you think about it. So the class, obviously, for the class variable, or the class, not class variable really, but for the class method, should be on the class level, right? So it should be accessed, the method here should be accessed by all the objects that you have. And then now for the instance method, it should be specific. It should be specific to the object. Now, we also talked about inheritance. It is. And for the bit of the inheritance, we talked about that reusability, whereby you can easily create our parent class, the parent class person, and then now off of the parent class, you can easily inherit methods or properties from the parent class. So that's what you're seeing here. We're inheriting something like professional practice off of the parent class. You have also method overriding and inheritance, whereby you can override a specific methods, as you can see here, after just inheriting the method of the parent class. And then now that should allow for customization, as you can see. And for encapsulation part, we did talk about, say, having the public and private. So obviously the private variable, in our case, then that means that if you have private variable, then that's only accessible within the class, and that should help with protecting data. And also, we kind of went ahead, talked about the access control that you'd have for this, and that's when I came up with or learned the property decorator. So that means that at this point, with property decorators, what you're saying is we're just getting the control over data access and also the validation of the same data. So for instance, for a case, we'd have the property here whereby saying we want to get the price attribute, and then this method, this getter method here should help with that. And then we have the setter, whereby for a case, if you don't want to change some values or make some changes, then we'd use the setter method, and that should help with that. And then also we have the deleter, as we mentioned, kind of to help us when you're deleting some values. So that's the encapsulation part. Now we also talked about, so there was the property decorator. We also talked about polymorphism, and you don't want to think about it as having something in many forms. And that means that in this case, we're implementing methods in different, say, different implementation of methods with the same name. And we saw that when creating our parent class animal, and then now we could go ahead and call the different, say, subclasses, and then obviously they'd have different, say, method implementation or different tweaks to the method. Like so, that will be mostly how you'd work around polymorphism. So just same method name, but different implementation, and that's how it go about it mostly. Now we finalized with abstract-based classes in Python, and we mentioned for the abstract-based classes they can't be instantiated, so we can instantiate this or create an object of that. But what we can do now is just inherit, right? They inherit the specific methods and attributes from the class. And in our case here, with the abstract-based classes, we mentioned that it acts as a template, as a main thing. You can think about it in quotes as a contract that other subclasses should follow. So our dog class, a dog subclass, and our cat subclass should follow that template where they have a sound method that be able to use. If they don't, then we saw how you're gonna get an error with that. You can see now how OOP will come in handy to build better system in terms of security, scalability, and robustness of the systems.